Okay, so this is the second video for today, and again for the second worksheet for today. So with these ones, we're going to do what we did in the first video, which is to change it into slope-intercept form, and then we're going to go ahead and graph it afterwards. So you should already know how to graph equations that are in slope-intercept form. That's something we've done already this year. And so it's just combining what we learned in the first video with graphing. So I'm going to start with number 2 because number 1's kind of a strange situation, as well as number 3. But let me go over number 2 here. So the first thing we're going to do is, again, we're going to try and get this to be in slope-intercept form, which again is y equals mx plus b. And I apologize for any sort of mess-ups. I'm going to do this in one take. I'm not going to start all over again if I mess up, but I'm going to do my best here. So as we learned in the last video, the first thing you want to do is try and isolate y is to move the x term to the other side. And the way you actually do that is by adding or subtracting it away from the left side. So this is a positive 4x, which means I'm going to subtract 4x. I'm going to do that on the left and on the right. So now we're looking at 7y equals negative 4x minus 7. And then the second step, again, was to get rid of the number that's multiplying to y, and we're going to do that by dividing. So the opposite of times 7 is divide by 7. Do that here and here. We're going to end up with an equation of y equals, now the 7 goes into both of these, negative 4/7 x, and then negative 7 divided by positive 7 is minus 1 or negative 1. So there's our equation that has been changed into slope-intercept form, into y equals mx plus b. What we need to do with that now is we got to graph it on the coordinate plane. There's a coordinate plane right here, so we're going to go ahead and start. Remember, the y-intercept is the starting point. So you're going to start at negative 1 on the y. So right there, and there's negative 1. And then the slope here, those are the directions. What do those directions mean? Well, the slope is negative 4/7. The top number is the vertical change. So that means to go down 4. And the bottom number is a positive 7. So that means to go to the right 7. So those directions, that slope, means to go down 4, right 7 from the starting point of negative 1. So from here, we're going to count down 4, right 7. So 1, 2, 3, 4 down, and then 1, 2, 3, 4, 5, 6, 7 to the right. Put our point there, and now we're going to connect those 2 points to draw our line. And okay, I'm going to make it look just a little bit better. Bear with me here. There we go. So there is our negative 4/7 sloped line from negative 1. And that's really all there is to it. So I'm going to get it into slope-intercept form. Go ahead and circle or box it so we can see where that is, and then graph it. So it's changing and then graphing. I'm going to go back over to these because these are weird ones, and they don't fit very well in this whole format here. But notice there's only one variable, it's x. So just go ahead and solve for x on these, and then I'll explain what to do. So you're going to subtract 7. So we get 5x equals 0. If we divide by 5, we've got x equals 0. So that means that what we're going to do is, remember, when you're missing one of the variables, it's just either a horizontal or vertical line that goes across that number. So this is x equals 0, so that means we have to cross 0 on the x-axis. And that's going to be right here. So this is just going to be a vertical line that goes across the x-axis at 0, which essentially is the y-axis. So there you go. That's number 1. And then look at this one here. Again, this is going to be a horizontal line at 6. So 1, 2, 3, 4, 5, 6 right there. So it's just going to look like that. Doesn't have to be perfect. But those don't really fit into this whole change in graph thing. So this one couldn't be put into slope-intercept form, so you just isolate x. This one already had y isolated. Technically, that's already in slope-intercept form. If you were to think of it like this, you'd have y equals, and there's no x, which means x, or the slope must have been 0. And so you would have started at 6 and gone up 0 and right 1. And so starting at 6 and going up 0 and right 1, and then drawing your line across like that. So you end up right there in the exact same spot that we already were. Okay. So let's see here. I think I can go ahead and do this last one here. This has got something slightly different from what we've done before. Think of that as a 1x. So as we're going to do this, subtract 1x on both sides. And we get negative 4y equals negative 1x. That's a positive 12, so we write it as a plus 12. Then you're going to divide by negative 4. So you'll end up with y is equal to, now again, it's got to go into both. And this is a negative divided by a negative, which is a positive. So that's going to be positive 1/4 x. And then over here, the 12 divided by negative 4 is going to be minus 3. So there is our equation in slope-intercept form. It's ready for graphing. We're going to start down at negative 3, down there, negative 3. And then we're going to go up 1 and to the right 4, which is right here. And then we're going to connect. So there's our line. Okay, that's, I think, pretty good for this assignment. The rest of them are a little more straightforward. So there is a bit of a tricky one right here, and I'm going to let period 1 skip that. Periods 5 and 6, I want you to give it a shot. So period 1 gets to skip this one, though. And again, if there's also not space on the graph, you can extend the graph a little bit to kind of finish it all up.